So I'll say kind of off the bat that this is going to seem pointless, what we're doing today in terms of using this Python wrapper, because everything we do is just going to be SQL queries. We're going to have just a SQL query as a string, and then we're going to put it in as a parameter to some. So it will definitely seem useless initially, and the reason we're doing it is kind of a transition from raw SQL to what we'll end up doing in Django, which will be at a higher level of abstraction than what we're going to see today. So this module that we're going to look at today that handles processing SQL using Python is called Psycopg2. And there's a couple different versions. We'll be using version 2, but version 3 is actually in development right now. So I don't know when that will come out, but presumably sometime in the not too distant future, there'll be a new version. And you can actually look at that. Let's see. So you go to the main page here. Here's the main page for Psycopg, and you can see that the Psycop3 project is currently under active development. And there's a blog. So this is maintained by a couple people. This guy right here is the main one. But you can read through the blog if you're interested in this kind of thing. He's designing a new system, so he's thinking about, he's kind of publicly posting some of the problems that he's having and how he can solve them. So from a software design perspective, it may be interesting to just take a look at this. But we're going to be concerned with Psycopg2. So here's the documentation here. You can also go to the source code. It might be tough to figure out since it's in C. You can look at. Anyway, so this is in C, so it's not going to be all that helpful, but the source code is available. And if you go to the documentation here, you can just kind of look through it real quick. So we have, let's see, basic module usage. So we'll import just like we always do. It's a third-party module, which means we're going to have to download it, which means we're going to want to set up a virtual environment. So we'll do all that in a sec. But so we have, we're importing the module, and then we have to go through a couple steps every time. So we're going to need to create a connection object. So that we'll use that Psycopg2.connect. So we'll pass it the parameters that we want for our database. And that connection object will basically, that'll represent in a general way our connection to the database, but that's not enough to actually do anything. So on top of that, or from that connection object, we will need to create a cursor object. And the cursor object will be what allows you to actually do things inside, creating tables or making queries, all the normal stuff we can do with SQL. So it's kind of this initial two-step boilerplate that you're going to have to do every time. So you create a connection object, then you create a cursor object. And once you have a cursor object, then you just basically pass it a SQL string. So there are a couple minor issues. You can look through the documentation. There are a couple warnings. So we'll talk about SQL injection towards the end. We'll have a module dedicated to security and that kind of stuff. So we'll talk more about that later. But the basic idea is you can execute a query. So here we're creating a table. You can see that this is just a string. So this is raw SQL. And we just are inputting it as a string. Insert, all the creating a table, inserting, and then making queries. So you can execute a query. In order to get the content of that query, there are a couple methods. There's fetch one, there's fetch all, so these these fetch methods are going to return tuples. So whatever you get, it will be in the form of a tuple. And then we also need, so after we're done, let's say we create a connection object, we create a cursor object, we execute whatever commands we're going to execute. And then if we're making changes, then we need to commit them explicitly. Otherwise, they won't be saved. They won't be saved permanently to the database. And then once you commit, you close the cursor and then you close the connection. So there's, is this easier and less complicated than raw SQL? No, not really. But it allows us to do it. That allows us to get things that we can do with Python. So whatever we're doing here, we can now use this in our Python code, which is obviously hugely important. So so that's the basic idea. There's going to be some boilerplate before you do the meat of your SQL, and then some boilerplate afterwards. You don't need to worry about memorizing all of this. The point is you're not going to be using this module directly, at least in this course. After today, or you can optionally do this on the assessment if you'd like. But the point is to just kind of, one, it's a third-party module, so getting used to reading the documentation and figuring out how it works. Two, to get you familiar with the idea of using SQL with Python. All right, so let's go back to the README for today. Sorry, one sec. All right, so we're basically gonna work through this, and so we'll start with a simple example, and then we're also gonna use an example where we're reading from a CSV file. So we're gonna end up reading from a CSV file, taking all that data, processing it, and then inserting it into a database so that we can use it. And the challenge for today will involve something similar. So I might as well just show you the challenge so you'll see kind of where we're going with this. So we're gonna get a CSV file from the city of Chicago. The city of Chicago has lots of publicly available information. So this is employees' names and salaries, and we can grab it as a CSV. And once we have that CSV, let's see, you'll see, a real live database being used for the city of Chicago. You'll see that it's maybe not the best design. There are definitely things that could be improved about it, and you'll see that. So you'll get that CSV, and then you'll want to clean the data, process it, and once you have it processed, you're going to want to insert it into a database, and then you're going to be running some queries on that data. Let's go back here. So the first thing we're going to do is install Psycopg2, but I would say, let's just say never. Let's just say never. You never want to just install third-party modules in your global namespace on your system. So you want to create a virtual environment. So can someone remind me how I can create a virtual environment?
Python-m for module.
Okay.
VENV, and then
okay.
The name of you want to give it.
Okay. Oftentimes it's just, you just do this, although it can be a little confusing initially. But so now we created this folder called whatever we wanted, called venv. So this is our virtual environment. So now I can just do pip install Psycopg2, right? Okay. So what should I do?
You have to source it first.
Yeah. So I need to activate the virtual environment source. Okay, so now I'm using my virtual environment. So now I can install it. Might take a minute. Okay, so now we have it installed. Now, if you're using an M1 chip, you may have issues. Just let me know if you have an issue with this. Okay, so now we have our virtual environment activated for our project, and we have this dependency installed. So we'll create a database that we're going to end up using. So create DB class roster. All right. And then I'll just copy paste this and then explain what's happening. Okay, so there are a few things we need to do. So we install Psycopg2. We're installing the OS, or not installing it, but we're importing the OS from the standard library just so we can do this. This is not strictly necessary. It's just, you could also just hard code your username. In any event, we're creating this connection object, and the minimum information you need is you need to tell it what the name of the database is. So the database we just created was class roster. This could be anything as long as it matches the database that you have. And then the user, which will be the name of your computer, basically. And the kind of odd thing here is that this is a string. It's not really, you pass it an entire string. So it's not really key value pairs. It's a string. So that's just something to note. Okay, so once we have a connection, we're going to need to create a cursor object. So we create this connection, then we create a cursor object. Once we have the cursor object, then we can start actually interacting with our database. So here we have a create table statement. So this is just a string. Create table students, and then ID serial primary key. So this should all look pretty familiar. Name, varchar, we could specify, but favorite food, varchar. So we've got 3 columns in this students table that we're creating. I'm creating the schema. This is not really a query. This is a schema, and then we can execute this command. So we just pass it in, whatever our query or whatever SQL command we want. And then in this case, we need to commit it because we're altering something. So we need to commit it explicitly. And then we can close the connection. You can also close the cursor. Are there questions about that? Okay, so let's try executing this. Okay, and we'll check it out. PSQL. We can see that we have this students table. So that worked. But so the way this is written is not really, it's not so great. So one question you might ask is what happens if there's an error, or what happens if we try to insert something and it doesn't work? So ideally, what you would do is you probably want to wrap either all of these individually in try-catch blocks, or you can wrap the whole thing, at a minimum in a try-catch block. And then what you want to do is make sure that you're closing the connection.
What was the difference between commit and close again?
So commit will basically, so we haven't done this explicitly with SQL, but so we are making a change to the database here, but it won't actually become permanent until you explicitly commit it. So it's basically creating a transaction. It's creating a transaction. You can do lots of stuff in a transaction, and it won't make that transaction permanent until you run commit.
Oh, and when we have been doing that in our schema SQL file, is that not getting processed in that same manner then?
Yeah, so so you can actually change this setting in Psycopg2 as well. So there's a setting called auto commit. So and if you use auto commit, then you don't have to explicitly call this. It will every command that you execute will automatically be committed. So that may or may not be what you want. It kind of just depends on your use case. So there's certain situations where you would want to use auto commit. And we'll actually see this kind of thing pop up when we get to Django. So sometimes you'll want to get information from the database, or like make and then alter some of that information and then make a final commit. So I wouldn't worry about this too much, but it's just something you should include if you're making changes to the database. So I'm gonna
Chad.
yes.
Yeah, I noticed that in the SQL query, it's got name varchar, but it doesn't say like how long it is.
Yeah.
Is that like a SQL thing that you don't have to say how long it is, or is that like a special case for this?
Yeah, so there'll just be a default.
Okay.
So the max for varchar is 255, I believe, something like that. So we could specify this. Well, we could try. Let's try. Well, maybe we'll see that an example of that later. Okay, so let me add a statement here just so we can drop the table, so I can run this multiple times. Here's that. So that will allow us to do this. So something like this, you want to make sure, so just like a file, so the API for the database is very similar to the file API. So you open it, but if there's a problem while the file is open, you need to make sure you're closing it. So you generally want to use a try finally, or try except finally. But these connection objects, because there's this repeating pattern where there's a lot of boilerplate, just like opening a file, you can it's also implemented as a context manager. So let's check out what's available on the connection object. So there are a number of, we get a whole bunch of different kinds of errors for databases. And let's see. We also have enter and exit. So we can see based on the Dunder methods that are implemented in this connection object, this connection class, that we can use it as a context manager, which means that we can say with this connection object, as whatever. Just like with a file, we can do with open myfile.csv as file, and then we can interact with that file object, but within this context. So if basically, in the case of a normal file, it will ensure that the file is closed no matter what. And with the connection object, it's basically going to ensure that if there's a failure in the transaction, that the transaction will be reverted. Okay. All right, so we'll add some records here, and I'll rewrite this one to use the with statement. Okay. I'm gonna just get rid of all these comments. Okay, so we still have to do the same thing. We create a connection object, but I'm going to use the with statement. So with Psycopg2 connect as. So now I have this connection object. It's basically the same thing. So I can access it here within the context with this name of con. And then I'm going to have another inner statement. So with con dot cursor as cursor. I can get rid of that now. So I can tab all these over. Put that in there. Cursor.close. Okay. So again, I've just kind of changed how I've written this to use the context manager API instead of trying to run a try catch block. But I have a connection object that I'm creating, and then a cursor object from that connection object. And then in here, I have a query. So I'm going to create a table, and I'm going to execute that create table statement. Then I'm going to execute some more statements. So I'll insert these three values, and these are substitutions. So this is the proper way to do this when using SQL. So one kind of naive way to do this is to just use string concatenation. But the idea would be that you're probably getting this kind of information from user input. So you have a form on an HTML page and someone like logs in, for example, something like this, or signs up. So they give you the name. I'm getting an echo from somewhere. Let me see. So yeah, so you, again, we'll talk about this in more detail later, but you never ever want to just directly take user input and then put that into your code, especially on a database. You're just inviting trouble. So there's some this helps with some of that. So you use this format. Okay, so we have these three statements, and then we can commit it, and then close the cursor, and then close the connection.
Since we're doing this as a context manager, will the exit automatically run the close statements?
Yeah, so that's a great point. It's so the context manager API doesn't really determine what specifically the thing has to do. So in the case of a file, closing the file is what it does on exit. But in the case of the database, it doesn't actually close it. It will revert the connection if there's a problem. So it could have been implemented in that way, but it just happens to not be that way. So you still have to close the connection. So I'm going to.
I do think that the con, like the connection is CONN, but down in 16 and 19.
Oh,
it's
thank you. So let me just change this to. I'm going to make sure I'm dropping the table to exist. So. So. All right, so let's go into our database, check it out. PSQL is called class roster. So you can see our students is there. So let's select everything from students. And you see that this stuff actually got inserted. Okay, so what if we wanted, so we've inserted everything. Now, what if we want to actually query it? We can also query it in our Python code. So let's just assume that maybe this is happening somewhere else, but we'll kind of start the process over. We'll create a new connection, we'll create a new cursor, and then we'll run a query to get what's in the information. So with Psycopg2 connect. So this will create a connection object. I'm gonna just copy this. Okay, so we have another connection object. Then we'll create a cursor object. Connection. Then we'll execute. So let's just execute a query. We'll get everything. So actually, it will stay on the cursor. Never mind. Select star from. Okay, so we can run this. Let's try running that, and then we'll do. So ideally, we should wrap it in this try. So ideally, your code should look something like that. So we can run the file, and it executes, but we don't. I mean, we're not seeing. So we ran the query, but we didn't really do anything with it. So in order to actually do something with the results of that query, we'll need to run we'll need to call one of the fetch methods. So cursor, let's look at the documentation. We'll look at the cursor class. So you can look at the documentation, the connection class, the cursor class. So this will describe all the methods that are available here. So a rollback and commit. Yeah, so if you're interested in what the context manager does, you can take a look at those. All right, so we have close, execute, which we've seen, execute many. So we had 3 individual statements here, but you could also use execute many, save yourself some typing. And results retrieval methods. So let's take a look at the cursor. Let's print out cursor. Okay, so there are a whole bunch of, let's see. So we can see that the cursor object implements next. So what does that tell us?
Tells us it's iterable.
Yeah, exactly. So we should be able to call this directly. So you could do something like for, we don't know what it is, something in cursor. Let's just see what happens. So we get the results right there of our query. So again, we did select all, so we got everything, and each row is returned as a tuple. So each entry is returned as a tuple.
And those would be blank if we ran that loop before we did the execute method.
Yeah. Well, let's see what happens. Yeah. Well, I haven't tried it, so let's try it. For okay, so we get a custom error from the Psycopg2 module telling us that no, we can't do this, that there are no results to fetch. Okay, so we could, so just like a file object, you can, let's say, you can directly iterate over a file object. You can also directly iterate over this cursor object once you have some results, but you know, I don't know what you should do, but you can also use these methods directly. So there's fetch one if you just want one result. So if your query is only going to return one item, you can use fetch one. You can also use fetch many, and this will basically it's like chunking. So if you have a lot of results, you can get sets depending on the needs of your application, and fetch all will just give you everything. So in this case, let's use fetch all. And here, instead of, here we get an array of tuples. And of course, we could loop over that, and it would look the same as what we saw previously.
Is it storing that in a parameter in the cursor instance? Because it runs the SQL query, and then the results come back. It must temporarily store it somewhere in the instance parameters.
Yeah, so let's take a look. There. You could also try looking at the. So let's see, we have row number, scrollable. I'm not sure where this would be exactly, but let's see if we can. Yeah. So this module is written in C, so we're not going to be able to look at the Python code directly. So I'm not sure how it works under the hood, but probably something like that is happening. Okay, so we can both, create a table, we can insert into it, we could also run queries. I can change the parameters here. So I can do select name from students. And I just get 1.
So Chad, just to clarify, that fetch all method is really doing exactly what we did with the iterable before when we did for
Yeah,
X and cursor.
kind of, except fetch all is immediately turning it into an array. So it's processing everything immediately. Whereas if you are looping over it, that will be an iterable. So it'll be kind of
You could do
lazy.
something else. Yeah.
Yeah. So it's a generator basically. So if you had 10 million rows returning from your query, you wouldn't be able to use fetch all.
And fetch many, you specify how many in the parentheses, is that right?
Yeah.
As a parameter? Okay, thanks.
So it's like chunks. You can get chunks of it and you keep going until it runs out.
And can you say like start at, entry 25 and go through 35?
That's a good question. Off the top of my head, I don't know. If you could directly include that as part of the query, or that's just something that you would process. You could do further processing in Python. So yeah, I'm not sure. Okay, so we have, so basically this allows us to do everything that we've been doing in SQL already, except once we have the results, so basically we can process them. So that's the results cleaned. Let's do something like, so this allows us to basically take whatever we're getting from our database and then further, whatever the particular needs of our application are, we can take that data and use it just as a normal Python object. Okay. So we'll look at a little bit more advanced case where we're going to use, we're going to get the data from a CSV. You can go click here to grab the data set. I actually have it right here already. So let me just. Okay. Okay, so here's the information we get from that CSV file. Oh, why it's not. So you can go here. If you want to try this yourself, you can also switch to the raw view. You can just copy and paste it into a CSV file. Okay, so let's create another database called Sacramento Real Estate, which is going to be based on the data that we have here. Sacramento Real Estate. Okay, we create the database, and then I'm going to skip this, but So I'm not going to use the IPDB, but and I'm going to rename this. It's just going to be called data. Okay, so we're going to open to, this is just normal, like what we've done before many times. So we're just going to open the CSV file. We're going to create a dictionary reader object, and then we're going to go through everything that's in the CSV, and we'll check it out. Okay, so you can see all of these objects. So not a terrible surprise, but there are a couple issues. One is that everything is a string. So we might want to do some processing before we insert it into our database. So let's copy this. And we change the name of the CSV again. Okay, so now we've got something. We're starting to divide this up into methods. You know, this could probably be a class or multiple classes, but we're just kind of doing it as a script for now. So we have this function, create table query, which is just going to return this string. It's just a convenience. So this is going to create all our tables. We have this function to clean the data. We'll look at that in a second. We're creating, we're not really using the with statement, but we could improve this and make it use make it a context manager. So we're going to create a connection to the database. We're going to create a cursor object, and then we're going to execute the table creation query, which is this. So we're going to execute that string. Then we're going to open. So keep in mind that this cursor is still open. So then we're going to open the CSV file. Again, we're going to create a bunch of dictionary entries out of the rows. And then for each row, we're going to clean the data. So we can see here that everything is a string, for example. So we don't want to do that. So we're gonna do some conversions. We're going to pass in a row, and then we're just going to go through, and anything that needs to be different, we're going to change it. If it's the same, so here we're just changing the column name because where's that? Street address. This is how our table is implemented. This is the name of the column, so we need to make this conform. So we're going to convert the name. So this is all the same. And then here, number of beds. So here, this is just a string because it came from our CSV file. So we're going to convert it to an integer before we put it into, before we insert it into our table. We're going to convert these as well. So this is, a little bit more complicated, but you can also convert it to a datetime object. And if you look at the documentation for Psycopg, you can see some of the correspondences between Python objects and SQL objects, SQL types. Okay. So once we have the data cleaned from the CSV file, then we're going to insert it into the dictionary. So in this case, we're executing a statement for each one. We could make this a little more compact, but that's fine. So this is very long and hard to read, but we have all these. We're inserting into properties all these columns. Again, this is not the best, the most well-designed database, obviously. We're going to insert it, and then once we insert everything, all of the rows in the reader, then we're going to commit. And if we don't commit, then it won't be permanent. So if we open the database later, it won't have any of that information in it. And once we commit it, then we close it. So let's run.
What about closing the cursor? Do you have to do that?
Yeah, so you should. So we should also be wrapping this in a probably in a context manager, or at the very least a try except finally block. Or kind of skipping that. So this is just to show you the basic structure of how this works. Python CSV example. So let's go ahead into the database. Okay, and we'll do select star from and we can see, let's look at the you can see that we have these types, so integer, longitude, and latitude. So this is a decimal type in Python. It's converted to numeric, so timestamp without time zone. So you can look at the documentation and see what the correspondences are. But so if we tried inserting, let's see. I won't do that now for the interest of time, but if there were an issue, let's say we tried to insert something and it was the wrong type, that transaction will get rejected. And if we're not handling an error, then it's going to create problems. So you're going to want to use the with statement.
Chad, can you review again in the values section of line 35, the modulus S's and how those connect with the dictionary?
You can basically think, so in terms of like Python string interpolation, there are a few ways that that's handled. So we have so you can do something like do something like this, where so this is a formatted string, especially in older versions of Python. There's a couple other ways of doing that. One is, let's see if I can, I don't know if I can remember. What is it? Might just be. I'm not sure if I remember this, but yeah, that doesn't work. Yeah, so there are other there are a few ways you can take a look at if you want, but one of them is you do something like this. So it's a little bit more convoluted. Let me see if there's a string example. Yeah, so using numbers, you can just do that. Yeah. So the basic idea is instead of here with the format string, which is a little bit more intuitive, you're directly kind of inserting things here. And if we had multiple values, you could just have a comma and then, so let's just do something like, And here it will, the order will be important. You could also do, I think one, if you wanted to change the order. So there are a few different ways, and it's a little, it can be a little confusing. But that's the basic idea. So there's something similar happening here, where we're kind of saying, here are a bunch of dummy values, and I'm going to tell you what they are later. And here is later. So, you know, obviously in terms of readability, this is terrible, but this is the first %s. This is the second %s, and so on.
Could we change that to use like a formatted string like the first example?
Yeah, you can, but there's a problem with that, which it increases your susceptibility to SQL injection attacks. The documentation mentions this. It's pretty emphatic about it. So, I mean, here at the documentation, it kind of tells you all these different variations and ways you should and shouldn't do that. Let's see. So here's a nice red warning. So never, 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 or sorry, yeah, three nevers. Never, never, never use Python string concatenation or string parameters interpolation to pass variables to a SQL query string, not even at gunpoint. So you definitely can do it and it'll work, but you're just you're leaving yourself more open to attacks. So there are other things you could do to mitigate that on your end. So if you get user data, you could do all kinds of processing on the front end before you inserted it into a query. But this is just kind of standard practice for this module.
So does the order matter in that second half of that? Once you start the dictionary?
Yes.
Yeah.
Yeah, the order definitely matters.
The S's don't magically like pull it into the right spot somehow.
No, there is a way to
They're
do
just
it.
placeholders, kind of.
Yeah, there's a way to do it with like a dictionary. I don't. I have to look for it in the documentation, but there is a way to basically have named versions of these, which for something like this would be better choice. Okay, and then if we wanted to run a query, let's just say, you know, are single family homes or condos more expensive on average? We could do the same thing we did before. So, well, let's do it in another file. Csv example. I'm going to copy this. You can set this up properly. So import all right, and then we can try it. Let's wrap this up. Okay, so yeah, the basic boilerplate out of the way. And what we want to do is write a query. So we can write that as a separate string. So if we want to get, let's say, what is it? Are single family homes or condos more expensive on average? We look at our data. We have type. So, I mean, it's not, we have residential and condo. So they're two types. And then we have price. So type and price are probably what we're gonna need to look at. So how do we do that? Are single family homes or condos more expensive on average? So if we were just gonna write this as a normal SQL query,
Average the sale price and then group by the type.
okay. So let's do select average price, and that will be was it type from so I'm gonna also use triple quotes so just to make it a little nicer. So select average price type from properties
Group by.
by type. So let's give that a try, and we'll have to use the cursor as execute method. So cursor dot execute the query, and then to actually look at the results, so we just saw there's a couple ways to do that, but I'm just going to use fetch all. So cursor dot fetch all. And we'll print that. Column price does not exist. Right. So why doesn't this exist? Because we changed it. Right. So we clean the data. We change this from price to, let's say, something a little more descriptive, sale price. So we'll change that price to sale price, and then type probably changed as well. So type, yes, we changed to property type. All right, let's see if this works. By no, what am I doing? I copied the wrong thing. Property type. Okay, so this might not be the easiest thing to read, but you can see that the condos cost on average 102,000, and the residential on average 92,000. So we could also, let's say, make this result a little bit more better, a little bit better. So let's do. Do something like this. Okay, so I'll pretty print the result. Let's see how that works. Let me convert this. Oh, let's make it a string. It's a little easier to read. Oh my goodness. Tuple. So okay, so what am I doing wrong here?
I think you're pulling in the full tuple. So I think you'd want to index into it. So it'd be like result 0 at location 0 and result 1 at location 0 to pull in like the decimal part
Yeah.
of the tuple, right?
Yeah, exactly. So the results that you're going to get back are going to be tuples. So so this should probably display correctly. Or this will be yeah. And then if I try to convert this, hopefully that will work. So something like this. If you wanted to make this more usable or readable, the point is that once you get the result, you can do whatever you want with it in normal Python code. So that's basically it. If you know SQL, or you can figure out how to do the SQL part, it's fairly straightforward. The queries, it's a little harder to write because you don't have if you want, you can open up a .sql file so you can get the syntax highlighting and everything and write your queries in there and then paste them in. That might save you some trouble. But yeah, so just remember that the basic difference is you can have some boilerplate before and after, which most of which you can handle if you use the with statement. And then you just run your queries and then processing data, because the stuff you're using will, if you're reading from a CSV, it's going to you'll read it from a file, it will get turned into a Python object, which you can use, clean, process, insert into a database. Then you can run queries, pull that information from the database, and then further process and do whatever you want with that information in your Python code. So that is basically it.
Chad, I'm trying to remember. I don't think we did this, but is it possible to, like, when we create the database in the terminal, is it possible to do all of that inside of Python?
I'm not sure if you can create a database. You probably can. You can create a database from. Let's just see.
You just have to import OS and just run a shell command, I guess. It's kind of backwards, but
You
it
could,
would
yeah,
work.
yeah, you could do that for using the OS module.
Yeah, like if I just wanted to run one command and do everything from Python.
Let's just see.
I guess you'd have to drop the database at the end every time too. Since the script's creating a new database, you have to drop it every time.
Yeah, in a development environment. Let's see. So here's an example of changing this auto commit. So you don't have to explicitly commit if you do this. That's fine. So I mean, I haven't tried doing it, but looks like you can. Okay.
Chad, are we going to be doing a review for